Okay, so good morning everyone. Today let us look at section 1.5 of the chapter, first lesson. Okay, so let us recall what we learned in the last class. In last class we saw that the decimal expansion of a rational number is always terminating, which means the digits after the decimal point they stop, or they are non-terminating recurring, non-terminating repeating. Non-terminating means it does not end, it keeps on going, and the digits in the decimal expansion they repeat, like 3 repeats here, 2 7 2 7 repeats here. So such a number, or a number whose decimal expansion stops, or it does not stop but it repeats itself, it will be a rational number. Then we saw that the decimal expansion of an irrational number is non-terminating, non-recurring, which means it does not stop and it does not repeat itself. Okay, so as you can see here, it is non-terminating because the digits in the decimal expansion there does not stop, and it is non-recurring because there is no other digits do not repeat in any of the patterns. And examples are root 2 pi. So this is true for all irrational numbers. So if we find any number whose the digits after the decimal point they are non-terminating and which do not repeat in any pattern, then that number will surely be a irrational number. So this is what we saw in the last lesson, and then we saw successive magnification, how to write or how to represent a rational number on the number line by successively magnifying the number line. So in this class, we'll look at operations on real numbers, how to add and subtract, multiply, divide rational and irrational numbers. Okay, so choose any two rational numbers you like. So here I have chosen 1 by 2 and 1 by 3. So now I want you to add them, subtract them, multiply them and divide them, and tell me what kind of number is your answer. So here I have chosen 1 by 2 and 1 by 3. 1 by 2 plus 1 by 3 will be 5 by 6. It is a rational number. It is in P by Q form. The uh, difference is also 1 by 6. It is also in P by Q form. The product is 1 by 6, again in P by Q form. And the quotient is 3 by 2, which is also again in P by Q form. So whenever you add, subtract or divide any two rational numbers, the answer is again a rational number. So we say rational numbers are closed under addition, subtraction, multiplication and division. Why do we say it is closed? See, suppose this is a bag of rational numbers. And from this, I am picking up two rational numbers, 1 by 2 and 1 by 3. And if I add them or subtract them or multiply them, the answer does not go out of this bag. Like, it is not an irrational number. It is the answer will always be somewhere inside this bag. So that is why we call it as closed. So the answer, so if you take any rational number, any two rational numbers, and try adding them, subtracting them, multiplying them or dividing them, there the your answer will again be a number which is inside this bag. It will not be an irrational number which is outside the bag. Okay, so that is why we call them as closed. Okay, so now let us try to do the same for irrational numbers. So you can choose any two irrational numbers. Here I am choosing root 3 and root 2. Okay, so root 3 is 1.732, this big number. root 2 is 1.4142. Okay, now I'm adding root 3 plus root 2. So you can see this is a non-terminating, non-recurring number, decimal expansion. Okay, so this is irrational number because it is non-terminating and non-recurring. So root 3 plus root 2 is again an irrational number. So adding two irrational numbers gave us another irrational number. But however, see, root 5 is 2.2360. It is not 3.41. So root 3 plus root 2 is not root 5. That is, if you take any two positive numbers a and b, then root a plus root b is not equal to root a plus b. Okay. Okay. Next, next let us look at subtraction. So again we have root 3, the decimal expansion of root 3. We have the decimal expansion of root 2. Now root 3 minus root 2 is, you can verify this using a calculator again. This is also a non-terminating, non-recurring decimal expansion. So this is an irrational number. So root 3 minus root 2. So when you subtract two irrational numbers, the answer is again an irrational number. But root 1 square is 1. So root 1 is 1. So root 3 minus root 2 is not equal to root 1. That is, we have two positive numbers a and b. Then root a minus root b is never equal to root of a minus b. Okay, now let us look at product. So we have root 3 and root 2. Now I am taking the product root 3 into root 2. So you first we multiply these two numbers. You can verify this with a calculator. So again we find a non-terminating, non-recurring decimal expansion. So this is also an irrational number. So multiplying two irrational numbers will give you an irrational number. So now if you check root 6, we get root 6 is the same number. So root 3 into root 2 is the same as root of 3 into 2, which is, so that is root, if you have two positive numbers a and b, root a into root b is equal to root a into b, root of a into b, which is equal to root ab. So root 3 into root 2 is root of 3 into 2, that is root 6, or root a into root b is root of a into b, which is root ab. Okay, next we try division. So division, when we divide, so I'm taking root 6 and root 3. So upon dividing this using a calculator, we get these two numbers by a calculator. We get root 6 by root 3 is 1.4142. This is a non-terminating, non-recurring decimal expansion. So this is an irrational number. So if we check the value of root 2, we can see that it matches the value. So root of root 6 by root 3 is the same as root of 6 by 3, and 6 by 3 is 2, so root 2. So root of a divided by root of b is equal to root of a divided by b, or root of a by b. So if we add, subtract, multiply, or divide two irrational numbers, in these four cases we get the answer as an irrational number. Okay, so now let us look at another situation. So here I am choosing another two irrational numbers. I'm choosing root 3 and negative root 3. So I'm taking a positive irrational number and I'm taking a negative irrational number. So when I add them, I get the answer as 0, which is a rational number. Okay, now if I take root 3 and I subtract another irrational number, root 3, okay, instead of using two different rational numbers, I can use the same rational number, irrational number. So I'm choosing root 3 in both cases. So when I subtract them also, I get the answer as 0, which is again a rational number. So now let us multiply two irrational numbers. So here I am multiplying root 3 into root 3. So my answer is, as we saw before, it will be root of 3 into 3, which is root 9, which is 3. So that is a rational number. So if I divide root 3 by root 3, it will be 1.7 something divided by 1 point that same number, and that will be root 1, which is 1, which is again a rational number. So in the previous 4 sums, we saw that when we add, subtract, or divide, multiply two irrational numbers, we got irrational number. But now we see that while adding, subtracting, multiplying, and dividing irrational numbers, we got rational numbers as the answer. So if we add, subtract, multiply, or divide two irrationals, the result may be a rational number or it can be an irrational number. So now let us look at the bag of irrational numbers. From this, I'm choosing two numbers, two irrational numbers, root 3 and negative root 3, and I am adding them. But the answer, it goes out of the box. It goes out of the bag. This is the all the irrational numbers, but the answer goes out of the bag, which is a rational number. So this bag is not closed. Irrational numbers are not closed under multiplication, addition, subtraction, and division. See, now can you understand what we mean by closed? See, here if I pick up two irrational numbers, here I'm picking up root 3, and again I pick up another root 3, and when I multiply them, the answer will be 3, which goes out of the bag. So this is not closed, but in the case of rational numbers, it was closed. Okay. Okay, so now let us, in the previous two cases, we saw how to add rational number and rational number, or irrational number and irrational number. So now let us see how to do when we mix an irrational number and a rational number. So you can choose any two. You can choose a rational number and an irrational number. I am choosing 1 and root 2. So root 2 is 1.41. Okay. So when I am adding, I'll get, when I add the before the part before the decimal point, I am adding, so it will become 2.4142. So this is a non-terminating, non-recurring number, so it is an irrational number. When I subtract -1, the 1 would go away, so and it will be negative 0.4144421363. So this is also a non-terminating, non-recurring number. So this is also irrational. So adding a rational number and an irrational number gives a irrational number. Subtracting a rational number and an irrational number gives a irrational number. Now let us look at multiply. So multiplying 1 into root 2 will be again non-terminating, non-recurring number, so it is also an irrational number. Dividing, you can verify this using a calculator, that is also a non-terminating, non-recurring number, so that is also a irrational number. So I would request you to try out examples of on your own and check whether all these facts are true, whether there are any examples that make any of these statements false. That something like, see here, when I am adding a rational number and an irrational number, I am getting an irrational number. So can you find two examples where adding a rational number and an irrational number will give you again a rational number. Okay,